Good day, grade 9 learners. Welcome to today's Natural Sciences lesson. My name is Sianda Madlala, and this lesson is brought to you by the Gauteng Department of Education. Right, let's look at today's topic. Today, we are going to be talking about the reactions of non-metals with oxygen. Do you still remember our previous lesson? We talked about reactions of metals with oxygen. So today we are going to focus on the reactions of non-metals with oxygen. And also this topic is found under the strand, matter, and materials for your term 2. Right, let's carry on. Let's look at the lesson objectives. This is what you need to achieve by the end of this lesson. So by the end of this lesson, you should be able to write out a general reaction of non-metals with oxygen. So you need to pay attention so that you are able to write out a general reaction of non-metals with oxygen. Secondly, you need to be able to write out the word equation and chemical equation for the reaction between carbon and oxygen. Why carbon? This is because carbon is also a non-metal. So you need to pay attention so that you are able to write out the word equation and the chemical equation for the reaction between carbon and oxygen. Thirdly, you need to be able to state that carbon dioxide forms during the reaction between carbon and oxygen. Number 4, you need to be able to write out the word equation and chemical equation for the reaction of sulfur and oxygen. So we're looking at two main things here, right? Writing out word equation and chemical reaction. Again for sulfur and oxygen, as you did with what? Carbon and oxygen. Then lastly, you need to be able to state that sulfur dioxide is a product of forms during the chemical reaction between sulfur and oxygen. Are we together, grade 9s? Right. Moving on. This information is found on the CAPS document on your page 67. Right, let's move on to your pre-knowledge. This is what we have done in the previous grades, and we're going to use this as our foundation for today's lesson. So in grade 8, to start with, we have done the naming of elements, right? So since we're going to talk about the reactions of non-metals with oxygen, oxygen is an element of which we named in the previous grade. And the non-elements, some of them we have named as well in the previous grade, in grade 8. We have done the properties of non-metals, and we're going to revise them again today. We also have done compounds in grade 8. Then in grade 9, we have done chemical reactions. Still remember? We have done compounds as well. And lastly, we have done the naming of compounds. Now let's check today's terminology, the important terms that you are going to come across and use as well to understand our topic. The first one there is non-metal oxide. What is this non-metal oxide? A non-metal oxide is a compound that is formed when a non-metal reacts with oxygen. Look at that word, non-metal oxide. It is formed as a result of the reaction between a non-metal and oxygen. Now, coal. I think we have heard this word before, or we have seen coal, right? Coal is a combustible black or dark brown rock which consists of carbonized plant matter, which is found mainly underground seams and used as fuel. We're going to talk more about coal today as well. Right, combustion. Combustion is a type of chemical reaction where a substance reacts with oxygen during burning to form a new product. We have talked about combustion also in the previous lesson. So now, let's look at the baseline activity. We're going to go through the questions together. Then I'm going to give you 5 minutes to complete the baseline activity. Right, number 1. It says, what group is sulfur in on the periodic table? You need to look at your periodic table, right, to identify the answers. What group is sulfur in on the periodic table? Number 2, consider the reaction of sulfur and oxygen. Consider the reaction of sulfur with oxygen, right? Then you tell us what are the reactants of this reaction. You have to write their names and formula. Number 3, what is the product of the reaction in question 2? Right? The reaction of sulfur and oxygen. What is the product of that reaction? Right? Then you write its name and the formula again. Number 4, now use the formulas of the reactants and products to write a chemical equation. Then number 5, we have to tell us when is a reaction balanced. Then number 6, you tell us that is your reaction above balanced. If not, you tell us why. And if yes, you also tell us why do you say so. So let's meet again in 5 minutes. Welcome back, grade 9s. I hope you were able to answer the questions that I gave you, right? Now let's be interactive. We have a WhatsApp interactive number that you can send us your answers or your questions which you may have as we continue with the lesson. The WhatsApp number is 082 760 2630. Let me repeat, 082 760 2630. Right, now let's look at the solutions for our baseline activity. Right, number 1, it said, what group is sulfur in on the periodic table, right? So when looking at your periodic table, did you find sulfur? And what group did you find sulfur? Sulfur is in group 16 of our periodic table. So remember to give yourself a tick, right, if you are correct. And if not, you write corrections as we move. Number 2, consider the reaction of sulfur with oxygen, right? That is the reaction, sulfur and oxygen. So you tell us what are the reactants of this reaction, then you write their names and formulas. Let's look at the answer. The answer is sulfur plus oxygen. Those are the names. Give yourself a correct. Then the formula is S plus O2. Then you give yourself a tick as well. Let's move on to number 3. What is the product of the reaction? What is formed at the end of this reaction between sulfur and oxygen? Also write a name and the formula. What is formed is sulfur dioxide. That is the name, right? And the formula is SO2. Now let's move on to number 4. Now use the formulas of the reactants and products to write a chemical equation. Your chemical equation is supposed to be like this, right? S plus O2, they form SO2. Now number 5. When is a reaction balanced? When is a reaction balanced? Remember we talked about what? Balancing of equations. So when is a reaction balanced? It is balanced when you have the same number and types of atoms on the reaction side and also on the product side. Let's read our statement there. It says, when you have the same type and number of atoms on the reactants and on the product's side. Now number 6, is your reaction above balanced? We are talking about this reaction now. Is it balanced? And if yes, why do you say so? And if no, why do you say so? Keep on interacting with us, right? And tell us your answers. Right, this is the answer. Yes, it is balanced because the number and types of atoms are the same on the reactants and on the product's side. Right, I hope you have enjoyed our baseline activity and we are ready to learn more. Right, to today's topic, we are talking about reactions of non-metals with oxygen. So we're going to talk about all the elements that are found on the right hand side, which are your non-metals, right? But they're reacting with oxygen. We have to talk about oxygen first. Where do we find this oxygen? Oxygen is found where? All around us in the air that we breathe, right? The air that we breathe, where do we find it? It is in the atmosphere, right? Which is a layer of gases. So an atmosphere is made up what? By a mixture of gases. What are those gases? We're talking about your carbon dioxide, we're talking about your oxygen, your argon, your nitrogen, and so on, right? But now the focus for today is oxygen, which consists of 21% of the atmosphere. So now, as we find oxygen in the air that we breathe, oxygen is a very reactive element. And in this case, we're talking about what? Oxygen reacting with what? With the non-metals. So now, as it is a reactive element, it means that it will readily react with many other substances. In this case, we're talking about non-metals. I'll keep on emphasizing. So now here's the question. Where do we find non-metals on the periodic table? Let's look at the periodic table and let's think. Where do we find non-metals on the periodic table? Let me remind you. We said that on the periodic table, we find metals, non-metals, and semi-metals, right? We said your metals are found on the left-hand side of the periodic table, which is this part here, right? All the way to here, right? Those are your metals, but excluding this particular element, which is hydrogen. I'll tell you why. Right, we have found the metals. Now let's look for non-metals. Non-metals are found on the right-hand side of the periodic table. So now, the second highlighted on the right-hand side, those are your non-metals. But what about these ones along the zigzag line? Those are your semi-metals, right? They have properties of metals and non-metals. Today's focus is on the non-metals, which are found on the right-hand side of the periodic table. Here is a cut picture of the non-metals. So all the elements here, starting from here, along this zigzag line, all these ones on the right-hand side of this zigzag line are your non-metals. For instance, your hydrogen, which I left out on that periodic table. Why am I saying so? This is because hydrogen is a gas. So therefore, it is a non-metal. Yes, it is placed on the left-hand side, right? But it is placed there because it was the first to be discovered, and also it is the first on the periodic table because of its atomic number. But in fact, it is a what? A non-metal. Hence, you see it here. So it's your hydrogen, your helium, carbon, nitrogen, oxygen, fluorine, neon, phosphorus, sulfur, chlorine, argon, selenium, bromine, krypton, iodine, xenon, and radon. All of those are your non-metals. Right. So now, properties of non-metals. We are talking about now the characteristics in which non-metals have. Right. First of all, they are poor conductors of electricity. What do we mean when we say they are poor conductors of electricity? It means that they don't conduct electricity, or they poorly conduct electricity. Therefore, we call them insulators. So in grade 8, do you still remember insulators and conductors? We said conductors, they conduct what? Electricity. Insulators, they are poor conductors of electricity. For example, we have a set of pictures there. We have a glass as an example of a non-metal. We have plastic, we have ceramic, we have a rubber, paper, fabric, cork, wool, and wood. Those are your examples of the non-metals which don't conduct electricity, right? Also, they are brittle solids. They are not malleable or ductile. When I say they are not malleable, what do I mean? I mean that they do not change shape. Instead, they do what? They break easily. Like the sulfur powder we have here as an example, right? It is an example of sulfur which has broken down. Right. Also, non-metals are dull and not metallic shiny. Not only that, they have lower melting and boiling points. Now, looking at our examples here, looking at carbon, phosphorus, and sulfur. All of these are examples of non-metals. And also, they are not what? Shiny. They are dull when you look at them. Phosphorus, as you look at this color, it is not shiny, and sulfur is not shiny as well. And all of the non-metals have lower melting and boiling points as compared to metals. Right. Now, reactions of nonmetals with oxygen. We're dwelling more on this topic now. So now, when a substance reacts with oxygen, we say it oxidizes. We say it oxidizes, and that product or that process is called what? Oxidation reaction. Are we together? Then, here is an example here. Let's look at this picture. We have 2H2 plus O2 forming 2H2O, right? We have hydrogen atoms here reacting with oxygen atoms to form 2 water molecules. So therefore, we say that these hydrogens are oxidized because there's an addition of oxygen atoms in between here, right? Now, moving on. When nonmetals burn in excess oxygen, the product, which is a nonmetal oxide, is formed. So it reads as follows. It says, when nonmetals burn in excess oxygen, nonmetal oxides are formed, right? So therefore, the nonmetal oxides tend to be acidic. What do you mean by that? They have a low pH. So remember pH scale, right? Which is that scale that ranges from 0, then you have 7 as neutral, then you have 14. That scale there, right? It means what? All your nonmetals range from 0 to at least 7, right? That is where they range in the acidity part, right? So now the general equation for the reaction of nonmetals with oxygen is nonmetal plus oxygen. They form a nonmetal oxide. Also, during the reaction of nonmetals with oxygen, you need to observe firstly the color of the reactants, right? The nonmetal as a reactant. And also the color of the flame in which the reaction happens, right? And also the last part, which is the appearance of the product, which is the nonmetal oxide formed at the end. Right, the reaction of carbon with oxygen. Why carbon? Right, we're going to talk about coal as an example because coal is an example of carbon, right? So now, have you ever seen coal burning in air? That's the question, right? Here is a picture of coal burning in the presence of oxygen. I believe we have seen this picture before, right? If it's not the picture, we have seen coal burning during the braais at home or when you are forming what? A fire, right? So now, I want you to observe the color here in between, right? When it is burning in the presence of air. First of all, what does coal look like in color, right? And look at the reaction now. Look at the color in which it is burning. And lastly, look at the product, right? What is the product? It is an ashy-like color, right? It looks almost like grain, eh? Right. So now, as an example, coal is a form of carbon, right? It is used as a source of fuel for many different purposes, of which I've mentioned now. Like when you are doing that braai at home, when you're having braai, when you are making fire, when you're lighting up that stove that requires coal, right? So now it is used as a source of fuel. But then this coal causes air pollution, right? And other environmental problems like global warming. It is a contributing factor to global warming, which is global warming is the increase of temperatures globally. Also, coal is used as a primary source of what? Fuel to generate electricity for our industries, for our activities at home, and so on, wherever we need electricity. Moving on, let's talk about how this coal is formed, the formation of coal. So as a result of dead plants and other biological wastes that were covered by layers of water and soil, coal is formed, right? Not only that, you have dead plants, biological waste that are covered by layers of water and soil, and the heat and pressure from the top layers cause the plant remains to turn into energy-rich coal. So you need heat and pressure to turn the dead plants and biological wastes that are covered with a layer of water and soil to make up coal. So now, the energy released by burning coal is used to generate electricity and electrical energy in coal-powered stations. We have talked about that, right? So now, when the non-metal carbon as a whole, right? The non-metal carbon, when it is burnt in oxygen, the product, which is carbon dioxide, is produced or formed from that reaction. Also, the word equation for carbon dioxide or for this reaction is carbon plus oxygen forming carbon dioxide. We also have the chemical equation. The chemical equation of the reaction between carbon and oxygen is C as carbon plus O2 as oxygen, forming CO2 as carbon dioxide. Let's look at now the model representation. If you look carefully there, you have one atom of carbon reacting with two atoms of oxygen to form a whole molecule or compound, which is carbon dioxide. It has one carbon and two oxygens. Therefore, we say it is balanced. Why am I saying so? Let's look at the reaction side. Reaction side, we have one carbon. On the product side, how many carbons do we have? We have one carbon, right? On the reaction side again, how many oxygens do we have? We have 1, 2. There are 2, right? On the products, they are 1, 2. So there are 2 oxygens again. That's why I'm saying this reaction is balanced, because we have the same type and number of atoms on the reaction side and on the product side. Right. Also, the reaction of carbon with oxygen, carbon is C and oxygen is O. It burns with a bright, luminous yellow flame looking something like this, right? And also, we can be able to test for the presence of carbon dioxide. This is how we can test for the presence of carbon dioxide, by using clear lime water, a test tube, and a straw, right? We pour in the lime water in the test tube, we blow using the straw, blow in carbon dioxide into the test tube, and the product shall turn milky white. Right. So now, when reactions of sulfur with oxygen, when sulfur reacts with oxygen, the flame becomes blue. It becomes a blue color. So now the product that is formed as a result is sulfur dioxide. So when you react sulfur with oxygen, a product which is sulfur dioxide will form. Also, that product has a choking smell. So this is the word equation for the reaction of sulfur with oxygen. We have sulfur plus oxygen forming sulfur dioxide. We also have a chemical equation for it again. You have S as sulfur plus O2 as oxygen forming SO2 as sulfur dioxide. Now moving on, let's look at the model representation. You have one sulfur reacting with two oxygen atoms forming SO2 as a result, which is sulfur dioxide. Right. This is the color that I'm talking about, right? When you react sulfur with oxygen, the flame becomes blue. Looking at this, sulfur as a solid, right, reacting with oxygen as a gas, they form a product which is sulfur dioxide, which is also a gas. And that reaction gives what? A blue flame. Now let's talk about the important uses of sulfur dioxide as a product. So sulfur dioxide is sometimes used as a preservative for dried fruits such as dried peaches, apricots, and also your guava rolls that we enjoy eating, right? So now, as this sulfur dioxide is toxic, it means that it is required in very small quantities, or it can be very dangerous to human beings and other living organisms. So we need what? Very small quantities so that we can be able to add it on top of food to preserve it. Here's an example of our dried fruits, right? We are familiar with this one here, our raisins, our peaches, and so on, right? Here's another example of our dried fruits which are preserved using sulfur dioxide. Also, in very small quantities, right? In very small quantities, sulfur dioxide does not permanently harm a large organism. Hence, I said it is required in small quantities, right? So if it is in small quantities, it does not permanently harm a large organism, such as a human being. But bacteria cannot survive at all in the presence of sulfur. So now sulfur dioxide is also an important preservative in canned foods like the ones we have here, right? Your baked beans, your tin fish, and so on. Now moving on. Right. But now, we're talking about reactions of nonmetals with oxygen, right? We've talked about carbon and sulfur. But not all nonmetal oxides are dioxides, right? As the following examples show. Let's look at the example here, which is the reaction of phosphorus and oxygen. Now look at that color in which the phosphorus is burning, right? This reaction is of a vigorous nature, right? Look at that color in which phosphorus is burning. It is bright yellow, right? And also, phosphorus is a very reactive nonmetal. So when phosphorus reacts with the oxygen, the chemical equation for the reaction is the following. We have 4p, meaning 4 phosphorus atoms, plus 5O2, meaning 5 diatomic oxygens, forming 2 phosphorus pentoxide. Right. Now I want us to count how many phosphorus are in phosphorus pentoxide and how many oxygen atoms are in phosphorus pentoxide. Now look at the ratio there, right? And let's count together. P as phosphorus, right? How many phosphorus atoms do we have there? We have 2. Are we together? How many oxygen atoms do we have in phosphorus pentoxide? We have 5. Are we together? Now moving on. Let's look at now the reaction between hydrogen and oxygen, because hydrogen is also an example of a non-metal. Right. Hydrogen and oxygen also react spectacularly, right? The reaction between a large quantity of hydrogen and oxygen in the air produces a beautiful orange fireball and a very loud boom, right? For example, we have a balloon here, which is filled with hydrogen, right? When it reacts with oxygen, as you can see here, plus O2, it reacts and forms that large orange fireball and a very loud boom then you cry that your balloon has popped, right? And as a result, it gives off what? Water vapor. Because it is the reaction now of hydrogen and oxygen. These hydrogens react and form H2Os, or they form H2O molecules, right? In the form of water vapor. Right. Let's look at the chemical equation for the reaction of hydrogen and oxygen. The chemical equation is 2H2 plus O2 forming 2H2O, meaning you have 4 hydrogens reacting with 2 oxygens to form 2 water molecules. Let's look at the word equation. You have hydrogen plus oxygen forming water. And also you have the model representation. You also have 2 diatomic hydrogens. So meaning you have 4 hydrogens plus 2 oxygens forming what? 2 molecules of water. Right. Now let's engage in this activity. Activity 1, I want you to listen carefully for the instructions, right? I'm going to give you another 5 minutes to finish off this activity. But firstly, let's go through the questions. Number 1, write down a balanced chemical equation for the reaction between sulfur and oxygen. Number 1A, name each substance in your equation. Then B, you draw a picture of your equation where you use red for sulfur and blue for your oxygen, right? Then number 2, you repeat question 1 for the reaction of carbon and oxygen. So now, when you draw a picture for question 2, use black for carbon and blue for oxygen. Then lastly, you need to tell us how can we test for the presence of the gas produced in question 2. Let's meet again in 5 minutes. Welcome back, grade 9s. Now I hope we are still enjoying our activities, but you are still waiting for your answers, responses, and questions if you have, right? The WhatsApp interactive number, it is 082 760 2630. Right. Let's look at our solutions for this activity. Number 1, you had to write down a balanced chemical equation for the reaction between sulfur and oxygen. The answer is S plus O2 forming SO2. This is because there's one sulfur on the reactions, one sulfur on the products, two oxygens on the reactions, and two oxygens on the products. Now, number 1A, name each substance in your equation. Your names should be like this, right? Sulfur reacting with oxygen, forming sulfur dioxide. Now draw a picture of your equation. Use red for sulfur and blue for oxygen. Let's draw this picture of the equation. Starting off, looking at the equation, right? It is sulfur. So you're having sulfur reacting with what? Oxygen. What color are we using for oxygen? We're using blue, right? So they react with oxygen, and we need a blue color for oxygen. This is a blue color for oxygen. We have two oxygen atoms, right? As a result, they form SO2, our sulfur dioxide, right? We have two oxygens. Let's clear the color. Right. We have two oxygens, 1, 2, with one sulfur, right? With one sulfur. Are we together? Now let's move on. Give yourself a correct. Let's move on to number 2. You had to repeat the reaction for carbon and oxygen. So when you draw a picture, you use black for carbon and blue for oxygen. Let's look at the answers first. This is the chemical reaction that is balanced. You have C plus O2 forming CO2. Then we have carbon, oxygen, and carbon dioxide. So let's draw again. We use black for carbon and blue for oxygen. Let's get a black color. So we have carbon plus oxygen. We have O2, right? We have two oxygen atoms. What color do we need to use? We need to use blue. So we have 1, 2. They form what? Carbon dioxide. How many carbons do we have? We have 1 and 2 oxygens. So you need 1 carbon and 2 oxygens in a blue color. Let's look for a blue color, and they are 1, 2, right? Then you give yourself a correct. Then you give yourself a tick. So now the last question there. How can we test for the presence of the gas produced in question 2? And our answer is we can use lime water to test for the presence of carbon dioxide. And when we test for the presence of carbon dioxide using lime water, the clear lime water will turn milky or cloudy when carbon dioxide is bubbled through it, to show that there is a presence of carbon dioxide. Now, the last activity. Now, let's do this one for 4 minutes, right? Let's do this activity for 4 minutes. Now, let's meet again in 4 minutes. Welcome back, grade 9s. Right, I hope you were able to answer this activity as well. Now let's look at this activity's solutions. Number 1, it says a compound in which carbon, hydrogen, and oxygen are bonded in the ratio 1:2:2 is, and the answer is, you have CH2O2. Why do we say that? This one stands for 1 carbon, right? This 2 stands for 2 hydrogens, and this 2 stands for 2 oxygens. Do we get it now? Now 2.1. If there is too little oxygen during combustion reaction of carbon, then the product is carbon monoxide. Write a balanced chemical equation for this reaction. Your answer is 2C plus O2 is equals to 2CO, meaning 2 carbons plus 2 oxygens forming 2 carbon monoxide molecules. Right, 2.2. What environmental problems is likely to be caused by people burning too much fuel that contains carbon? We talked about this in our lesson, right? We said it can cause what? Global warming. Don't forget to give yourself ticks for your correct answers, right? Now 3.1. Write a balanced chemical equation for the reaction of sulfur with oxygen. Then you describe the smell and appearance of the product. Our answer is, this is the balanced equation, sulfur plus O2 forming sulfur dioxide. And the smell is, the product is a choking, colorless gas. So it has what? A choking smell. And it is very dangerous for people with asthma. Moving on, it brings us to the summary of our lesson. So today we were talking about the reactions of non-metals with oxygen. You still remember? As we did lastly, talking about metals with oxygen. So today we said that when a substance reacts with oxygen, we say it oxidizes, right? And that reaction is called the oxidation reaction. You still remember that? I gave you an example of 2H2 plus O2 forming 2H2O. And we said in that example, we said that these hydrogens are oxidized, right? They are oxidized. Therefore, that's why you have this as a product. They're 2H2O. We talked about that nonmetals react with oxygen to form nonmetal oxides as products. And we said that the nonmetal and oxygen gas are the reactants of this type of reaction, and the nonmetal oxide is the product. So for your reactions, you have a nonmetal, which can be carbon, and oxygen, right, as your reactants. Then the product that will form is a non-metal oxide. Hence we have carbon dioxide. Carbon being the non-metal, oxide coming from the oxygens, right? We talked about that the reactions of carbon and sulfur with oxygen are examples of non-metals reacting with oxygen. And we talked about them, right? We said the reaction of carbon with oxygen forms carbon dioxide, which is a contributing factor to global warming again. We said sulfur reacting with oxygen forms what? Sulfur dioxide. That sulfur dioxide, it becomes what? A blue flame, right? And also it can be used as a preservative for our dried fruits and also tinned food, right? We also talked about carbon and sulfur both form dioxides with oxygen, but this is not the same for all nonmetals. Still remember our example for phosphorus pentoxide, which is P2O5, right? Phosphorus pentoxide. You still remember? Right, now let's use this concept map to summarize our lesson for today. The main topic being reactions of nonmetals with oxygen, right? So during this reaction, burning is a process, right? During this reaction of nonmetals with oxygen, there is some burning called combustion, right? So now, in the reaction of nonmetals with oxygen, some nonmetals such as carbon and sulfur react with oxygen to form a non-metal oxide, right? So now, for carbon and sulfur, carbon forms carbon dioxide, right? And for sulfur, sulfur forms sulfur dioxide. That is all that we talked about today, and that is what is important for you to grasp and know. So for now, let's meet next time when we're talking about acids and bases. So remember to stay at home, wear your facial mask, keep on sanitizing and social distancing. For now, thank you and goodbye.